Okay, so let's take a look at this last word problem. And again, lots going on, trying to draw a good picture of what's happening, and then hopefully we'll get lucky and see if we get a nice 90-degree angle in there, and we can just use the Pythagorean theorem to finish it off. In this case, what we begin with is we have two radar stations are located on a north-south line. So that basically means, here's my north-south line, and I have a station up here, right? And I have another station down there. So that's what that first line basically represents. So we have two radar stations, A and B, all right, and they're basically located on a north-south line. And then what we're told is that from the radar station A, so up here, we have a plane of bearing 129 degrees is 10 miles away. So now remember, this is a single degree, so we're basically talking from true north, right? So let me even change kind of colors here. So from true north, right, the bearing is going to go past 90 degrees, right, and we're talking about a 129 degrees. So we're talking about having a plane that's 10 miles away, right? So here's our little plane down here. Maybe that looks a little better than my cars, right? And that's the situation. So on a bearing of 129, so from radar station A, on a bearing of 129 degrees, it picks up a plane that's 10 miles away. Okay, so there's our first picture for that guy. Then it says that from radar station B, well, there's where we basically have a bearing of 139, or excuse me, 39 degrees. So again, we're talking about being on the south, north, and then we're rotating 39 degrees this way. All right, and then that's basically 6. So there's basically our situation, and what they're asking for is use this information to find the distance between the two radar stations. So we basically, let me highlight it right here, want that distance. Okay, so there's our situation, there's our picture, all right, and when we first initially look at this, this looks like one of those situations where, maybe we find something that's perpendicular to here, break this up, I have a 90-degree angle, and then I break it up into pieces. But again, like we learned from this, before we start doing all that work, let's just make sure, right, is there a 90-degree angle in here? And hopefully it's this one right there, but let's go ahead. We already know that this is 39, so what's this angle right there? Well, it's a supplementary angle to 129, so if I take 180 and I subtract 129, let me do the math here. Right, we end up with 51 degrees. So this is 51 degrees right there. And then, right, so as far as this triangle is concerned, that's 51 and that's 39. So if I add them together, lo and behold, right, these two guys are complements adding up to 90. And since this is a triangle, that basically forces this guy to be a 90-degree angle. So again, we got very, very lucky. Because there's a 90-degree angle here, we can avoid all that long, hard work where we, maybe break this up into two pieces, find D1 using the information up here, find D2 using the information here, then adding them together to get D. Because of the orientation, because of a good drawing and what I see, right, we actually have a 90-degree angle there. So reorientating myself, right, this is 10, this is 6, right, and there's the distance that we're trying to find. There's my 90-degree angle. So again, we got very lucky. Okay, so don't always count on that. I think almost 90% of the homework, most of the homework problems are going to be like this. So just draw a good picture. Make sure you have a 90-degree angle so you can avoid some of those rough right triangle situations that we did earlier. But it's doable, right? Breaking it up into a D1, D2, and using that and that to put it together. Maybe I'll even do that to check the answer. But at any rate, right, what we end up having here, this is 10. So to find that distance, we're basically using our Pythagorean theorem yet again, because we got lucky. So d squared is 36 plus 100. D squared is 136. Taking a square root, we've introduced plus minus. And so D is basically the square root of 136. All right, let me see if 136 breaks down. So 136, if I divide it by 2, I get 68. If I divide it by 2, I get 34. If I divide it by 2, I get 17. So this looks like this is basically 4 times 2 times 17. So it's definitely, in simplifying this, our distance is 2 square roots of 34. All right, and so there would be an exact answer, right, in terms of their distance. Of course, if I use my calculator here, right, the square root of 134, right, that's roughly 11.575 and 8. All right, and so there we go. Again, it's all about drawing a picture, getting yourself oriented, and in this case we were very lucky because we ended up with another 90-degree angle to basically take a look at. All right, and I think just for the practice sake, how about we approach this the other way? I'm going to actually cut another video here, and let's just see if the sum of those also equals to that, and that'll just basically kind of support that other idea that we did, right? But possibly a new video coming soon. Let me debate that one because I think this has been a long module. Alrighty, so we got everything that works. Right triangle worked. We're good to go. All right, and there's your bearing problems. That pretty much wraps things up unless I decide to make that other video here. I'll talk to you guys a little later.